In this chapter, we will have a look how correctly use Redshift object tag. Select object which you would like to use with object tag. Go to Tags, now Redshift tags, Redshift object. And here is our Redshift object tag icon. We have basic section when you can change the name, visibility section, and if you would like to use visibility section, you have to click on the override. And as you can see, that's exactly section when you can play with the visibility of the objects, their shadows, reflection, refractions, or with global illumination and caustics as well. As example, if we will turn off primary ray visible, we don't see anymore our entire object, but we see his shadows, his reflection, and also his collision with the volumetric light. Or as another example, we can turn off visibility in the reflection, and as you can see, we don't see reflection from our object anymore. Or if we will turn off secondary ray visible, you will immediately lose the reflection and the refractions contribution from our object. And of course, the same workflow working for shadows, global illumination, and how to use correctly object tag for photons and for caustics, I will show you in chapter Caustic Workflow. So if you need to have control of visibility of your reflection in surroundings objects, your shadow, refractions, or other stuff, use Redshift object tag, where under visibility you have full control of these operations. Next section we have geometry, where we have control of tessellation and displacement. And in displacement chapter, I will show you all details about those parameters and how correctly use them. Next we have Mate section for mate correction. Next is Object ID section, where you can change object identification number. Don't forget to click on override if you would like to use it. Next section we have Motion Blur. For Motion Blur we have separated chapter, where we will have look on all important details. And as last section is Exclusion, which has exactly the same workflow as Cinema 4D objects or Redshift light exclusion. So you should understand already how it works. In this example, I will show you how we can make visible our lines or curves with Redshift object tag. Go to Tags, Redshift tags, and Redshift object. Select your Redshift object tag, and as you can see, we are getting new tab with name curve. And if you will change mode from disable to hair strands, immediately you can see in our render view that we are getting visible results. And we can use scale graph to change scale of our curve across her length. And also we can change thickness, so let's to make our curve more visible. And as I will change position on the end now as well, you can see how I am changing shape of our curve. And if you need to add more points, push Ctrl and click on the curve, and after that you can drag with points. So as you can see in our render view, you have full control of scale changes across the entire length of our curves. And you can use different kind of the shapes as boxes. And I will use higher values for thickness to see it even more obvious. And again, you can use scale graph to change shape of your curve across the entire length. Or if you need, you can use right mouse button and reset your curve. And now it will be much more easier to manipulate with your scale. As next mode, we have cylinders. Or we can use also capsules, cones. And as you can see, cone mode has different size on the beginning and different on the end. So again, you have ability to manipulate with your scale curve. And last mode is strips. So again, we can use the same workflow. And also if we need, we can change interpolation, use resample or mesh subdivision. And as last example, we will have look on the particles visualization. And again, we have to use Redshift object tag. Go to Tags, Redshift tags, Redshift object. And again, Redshift recognized that we would like to use particles, so we are able to set up our particle visualization now. Switched from disable mode to point instances, and immediately we can see how looks our particles. And we can change scale of our particles to changing scale multiplier. But if you would like to change look or color of your particles, you have to apply material on your particles, and you will do those changes in shader graph. Let's to have look at looks other modes. Next mode we have sphere instances, and as you can see it's nice 3D representation. We can use also quad instances or optimized spheres, which are not so heavy for our computer performance. And as last we have custom objects, where we can use any object. So let's to try as example some torus. We will change scale of our torus, select our object tag, and drag and drop torus into the custom objects field. Change scale multiplier, or if you would like to keep default value for scale multiplier, you always can change scale of torus directly. And as you can see, as we are changing scale of the object, we are affecting final results of scale of the particles as well. And now if you will apply material on your torus, as you can see, it will change look of your particles as well. In this chapter, I will show you how to use photons and create caustics. And as you can see, we will use region to speed up our workflow. Select object, which will cast caustics. Go to tags, Redshift tags, Redshift object. Under visibility section, turn on override, and you have to enable cast caustic photons. Without this feature, Redshift will not render caustics. As next step, select your light, which you are using to create your caustics, and go to Photon tab, and here we have caustic section where we have to enable emit caustic photons. Now you have correct setup for caustic visualization, but still we can't see in our render view any caustics. And reason is because progressive rendering is not supporting caustics. You have to switch to bucket rendering to be able to see your caustics. And now you can see that started our caustic visualization. Starting point looks always very grainy and needs time to calculate, so you can expect that your workflow will slow down. Go to Render Settings, and under Redshift section we have Photon tab. Click on Photon tab, and here as you can see we have Photon section where we can change the parameters. All those changes are non-stop calculating, so pause your render view if you do not need to see them. As next step, I will show you how to change number of photons to get much better results. And this time is going to be really big changes. Currently we have only 100,000, so as first step we will use 1 million. And as you can see, immediately we are getting much better result. But more photons you are using, more calculation has to do Redshift. So it will increase your render time as well. As next step, we can use intensity multiplier, which will increase visibility of our caustics. And as you can see, we have brighter, better looking caustic, but also now is more visible his noise. Let's to increase intensity even more, and also we will change number of photons from 1 million to 10 millions. And now we are getting nice clean results and cool looking caustic. Let's to have look on our photon settings. As first you can change mode, rebuild mode, saving calculation and photo mapping data on the disk, so later you can use load mode and load them. But rebuild don't save, recalculating every single frame without saving. As next we have tracing depth sliders for reflection, refraction and combined. Usually default values working just fine, But as example, if you don't want to use reflection tracing depth, just move slider to 0, because those settings are numbers of times that photons may bounce around the geometry, so more tracing depth means more calculations. And in our render view, you can see how it looks when instead 10 we are using 5 tracing depth. As next we have maximum number caustics photons, which controls the maximum limit of photons that can be stored in search radius. More photons you are using, more memory you will need, but it not always mean that it will improve image quality. Around 200 photons should work just nice. Next we have caustic search radius, and it controls the distance around each shaded pixel that will be used to find photons. Larger values mean smoother but blurrier results. And as we can see in our render view now, search radius more than 20 completely destroyed our caustic. And now I will show you how looks search radius 3, search radius 1, and also search radius 0.1. And here is tracing depth example with reflection 0, and one more example 134 when we have not enough refractions tracing. So be careful about lower numbers in your tracing depth optimization. As you can see in our photon section, we have inactive enable GI, max num GI photons, and GI search radius. All those parameters working with GI section under our lights. So we can use photons for global illumination as well. But first we have to go to GI section and enable as our primary GI engine photon map. Go to photon section, and now as you can see we have active enable GI, max num GI photons, and GI search radius. And if you will enable emit GI photons, you will have global illumination setup with photon map. But it produces very noisy results, so you need a lot of photons to clean it up. That's main reason why I prefer brute force instead. And this setup is not affecting our caustics. But now you will have idea why we have all those parameters under photons section. For caustic visualization, we have to switch to bucket rendering. As next step, select your light, and under photo section, enable emit caustic photons. Select object which will cast caustics and use redshift object tag. Enable override in visibility section and enable cast caustics photons. Select your light and under photon section increase intensity multiplier and also increase number of photons to emit. Select material applied on torus. Go to shader graph, and here I will show you how material affecting looks of the caustics. In preset menu, change from plastic to glass. And as you can see, refractive material creating much more interesting caustics. Increase number of photons to get cleaner result. And now I will show you how dispersion of refractive materials creating color variations for our caustics. Values between 0 and 1 creating the most colorful results. And in our render view you can see how looks value 0.1, 0.5, 0.7, and 1. Also 10.4 or 34. In this example, we can see how looks caustics from tinted glass, which is subsurface material, and how will change color of the caustics if we will use dispersion 0.2. And one more example is gold material, so we can see how looks caustics from metals. In this example, I will show you how IOR affecting looks of our caustics. I'm using dispersion 0.4, and in our render view, you can see how looks caustic with IOR 1.1, 1.3, 1.5, 1.75, 2, 2.5, and 3. And now I will show you how lights and their positions affecting looks of the caustics. Currently we're using spotlight and we will change it to point light. And now to area light. We will increase intensity of the area light even more and even more. And now we will change position so we can lower our intensity. And now back to spotlight. And we will also change position of the spotlight. So as you can see, all those changes affecting look of your caustics. And on the end of this chapter, we have bucket render with 10 million photons. We are using glass material with dispersion 0.2 and the refraction needs 1024 samples to clean out noise. But more details how to clean out noise we will have in chapter render settings.